Welcome to the College of Education.
Specific types of questions you want us to go over, we can go over those types of questions. I just pulled up the general knowledge, the GK test. You scroll down, you see that the math subtest is 1 hour, 40 minutes. And let's see, you know about all this general information.
Yes, ma'am, I do.
So what I was planning on doing was just going to the sample questions.
Okay.
Here, and then just doing some of those together.
Okay.
Does that sound good to you?
That's fine. Yes, that's fine. I know I scored really low in algebra, and
Okay.
I can understand that because when I was in school, I took algebra 2 years back to back just to pass algebra 1. So that was a little struggle for me. Yeah, so it was my algebra, and I know the probability and statistics. It was a little tricky, but yeah.
Okay, well, let's focus on that. And do you have a copy of this reference sheet?
Is that off the? No, I don't. I have it, but I don't have it. I have it with me. It's somewhere in my room with all my other math books.
Okay,
I do have it.
You're aware of it. You have.
Yes, ma'am.
Okay.
And that was what was on the test.
Yes.
They gave
me
a
allow
sheet.
you to have
Yes.
that reference sheet, and they allow you to have a on-screen calculator.
Right, which I got to get used to that because I have a clue that probably that's why I don't know. I can't blame the calculator, but it was really old school. So yeah.
Yes, it says this is a 4-function calculator, so very basic, nothing fancy.
Right. So I need to buy me one of those so I know how to hit the right one to get my answer.
Okay. Let's see. Where are let's go back to tests.
What I think? I think it should have been right there where it says the materials, but I'm not seeing it. Oh, there it is. It should be. Yeah, no, not that.
Well, we want the general.
Right.
Okay.
That should be it. It should be. Yeah, it's coming.
Here we go. Okay, so 40 questions are total. You know about this. 100 minutes long. A, B, C, or D. So we're just gonna go through some sample. But I know you only have an hour or so before you.
Yes. Yes, ma'am.
We're not gonna do all of them.
That's fine.
So when you look at a question like this, do you feel confident with fractions, or are you?
Kind of, sort of, because let's say, okay, so and I get confused too, as well as with the greater and less than sound. I try to remember how the teachers teach with like the open mouth is greater and the other mouth is that way is less than, but that still gets confusing as well. I know when it comes to fraction, putting them on a number line, that's confusing with me too. I have a hard time figuring out, like, where the 0 is at and the 1 is at and where these numbers fit. That is confusing to me.
Okay, so
yeah.
What I'm going to do is you see this question, I'm going to stop sharing. I'm going to go to my whiteboard. So I can write it down. And so it says -1/3, and then it had the box, and then -2/5. So one of the ways you can do this pretty easily is you can actually convert fractions to decimals.
Okay.
Because you have a calculator, it's really easy to do that.
Okay.
So On your calculator, do you have one in front of you, or do you have like a phone you can use?
I have a phone, but I had a calculator, but I think I had to move it because my kids were playing with it, and it was just on this table. But I have my phone.
Okay, so you can use your phone calculator for now.
Okay.
So divide 1 divided by 3. What do you get?
So do I do 1 over 2, or do I do 3 over 1?
1
Right.
over 1 is your numerator. So
Okay.
1 over 3.
Okay. So it's 0.33, which
So
is repeats.
because of the negative is negative 0.33, repeating, right?
And repeat. Yes, ma'am.
Okay, and then if you were to divide 2 divided by 5 on your calculator, what do you get?
0.04, which is 0.40. So I put another. Yeah.
Okay, so 0.40, 0.4.
Okay.
Okay, so now that we have decimals, it's easier to put them on a number line. So here's the
Okay.
0, and then we can just go by negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5, etc. Right?
Mm-hmm.
So negative 0.33 is going to be approximately here on your number line.
Okay.
And then negative 0.40 is going to be approximately here
Okay.
on your number line. So the question's asking which sign do we put in there? So which of these two is the biggest?
Well, it would be the 0.4.
No, because
No.
negative, right? So think about money. Would you rather
Okay.
have money or positive money?
Positive. Okay. So I need to be going that way.
Which one's
Okay.
positive? If positive is over here,
Mm-hmm.
which one's closest to positive? Which one's closest to 0?
It's the negative 3.33.
3, right? So that
Okay.
one is actually greater
Okay.
because you want to be less negative. Like the bigger negative you are, the smaller you are.
Okay.
You'd rather owe $1 than owe $5.
Right. Right.
Even though 5 is bigger than 1, when you put a negative sign,
It changes the value.
right, it's
Right.
flipped. It's better to owe 1 than owe 5. So negative is greater than negative 5. Negative 1 is greater than negative 5 because they're negatives, but 5 is greater than 1. But when they about negatives, the smaller your negative, the greater it is.
Okay. Okay. Right. Small negative.
So whenever I have trouble thinking about what fraction is bigger, I always think money, because everybody knows how money works, right?
Right. Right.
In terms of money, you know that negative is a bad thing.
Right. Yes, I do know that.
The closer you are to positive, the greater you are.
Okay. Gotcha.
So in this case, negative 1/3 is greater than negative 2/5. So we can go back to the test and we put a greater than sign, which is choice C, because that greater than sign is going to point to the negative 1/3.
Okay.
All right, are you good with that?
Yes, ma'am.
Okay, so let's see what we got next. I'm gonna skip around. We can always go backwards, but I want
Oh, that one is too. Yeah, great. Yeah, I seen that, something like that, similar to the test. And what I did was I put everything in a decimal point and made it into the percent sign, kind of, sort of ish. That's what I did.
perfect. So why don't you try it now?
Okay.
So if you can use your calculator,
Okay.
all of these into decimal form, and tell me which one is the lowest.
Okay. Okay, it is the 6/10. I got 6/10 because it's 0.06, which is 60%.
Okay. And you are correct.
Okay. All right. So I did that one right.
Yes.
Good, good. Okay.
See what we got. Got what about this one?
Okay. A building 51 feet tall, cast shadow plate. So we're looking for how tall is the statue? That's what they asked me for. Yeah. Okay. So right now I see 3 numbers, and I don't know. That's not Pythagorean theorem? I don't think. Or is that the like? I got to figure out what where we're. I know just say how tall is the statue, but I don't know. We're looking for it, which is the height, correct? So it's like more like the area, like baseline height. Like I'm not sure.
So the first part is a building that's 51 feet tall. So that's straight up. Tall, casts a shadow. A shadow is always like a diagonal. So you're right. It is like a triangle.
Okay.
The building is 51 feet tall. The shadow is always at an angle that's 48 feet long. And they have a nearby statue that has a shadow of 16 feet. And you want to know how tall the statue is. So this is sort of like similar triangles where you have, I'm going to go to my other screen so I can draw it, where you have the building stands tall, and then it casts a shadow. And then you have a statue that stands a certain tall, and then it casts its shadow.
Okay.
So you're right. When you fill in the bottom, which is the ground, you do form an angle. So these are right triangles.
Okay.
So this bottom part is the ground. So they told you that the building is 51 feet tall. So we can label this side 51 feet. And they told you the shadow is 48 feet long. And then the nearby statue has a shadow of 16 feet long. And then you want to know how tall is the statue. So you want to know this value here.
That side. Okay.
So it's always good to draw pictures like this
to
illustrate, what's going on.
Right.
So they don't have it. And whenever you have geometry or something and they don't have a diagram drawn for you, like draw one for yourself and label everything.
Okay.
So because these are both triangles and they're both right triangles, we can do what's called a proportion to find out the statue is.
Okay.
So what would our proportion be?
So I would do, and this is me, I would do 51 over X because those are the same 2 sides. And then I do 48 over 16. Is that correct? Or no?
51 over X.
And 48 over 16.
Perfect.
Okay.
Okay, so then how would you solve this?
Well, I know 51 can't go into 16, so I'll just cross multiply.
Right, but even if it could go in, because of the equal sign, you can't cancel across the equal sign.
Okay.
So if it was multiplication here in the middle, but it's equal, so you have to cross multiply.
Okay.
So 48x equals 51 times 16. This is when your calculator will come in very handy.
Yes.
So what's going to be the value for x?
Okay. 17.
Right.
And that would be the answer. Okay. That was easy. It's coming back to me. It's like I just got to remember this stuff.
Yeah, I mean, you did that pretty well. Yeah. So yeah, 17 is choice A, so that's correct.
Okay.
All right. So notice how that was geometry, but it was algebra too. Algebra. You had to solve the equation. You had to set up the equation with proportion and solve it. So algebra is kind of everywhere. It's in geometry. It's everything you do. Algebra is kind of like the base, the basis.
The base for all the math.
Yeah. Okay, so here's another one that requires you to actually draw a diagram. You have a rectangular animal pen. So they tell you you're thinking about a rectangle.
Okay.
So let's see if you can get this one.
Okay. And it's we're built using 200 meters base. Okay, so we're finding the area of the rectangle, and I think area is what, one half times base. Is that it?
So for a rectangle,
is it base times height? I'm not sure. I don't have the thing in front of me.
For a rectangle is just base times height.
Base times height. Okay. So okay. So it says it's 60 meters. So if it's on one side, it means it's on the other side. This is on the other side as well. Correct.
Right.
Okay, and then the 200 is the whole thing. I guess that's the meters of the whole fencing. Is that correct? So I got a question. So if it's 60 on one of the same side, is it 60 on the other side as well?
Yeah. So let's say you have, yes, if it's the one side is 60 meters. The side that's parallel on the other side is also 60.
It's 60. Okay.
On the left, and you have 60 on the right.
Right. I got that. So, but the other two sides, that's the one that we're looking for, correct? All right.
But look here, it says that you have 200 meters of fencing total.
So that's the total, correct?
So on one side you have 60, on the other side you have 60. So how much fencing have you used so far?
And that's 120.
So what do you have left over?
Oh, okay. From the 200. Okay, that's what. Okay. 80.
You have 80 left over.
So that means that's those other two sides.
So the other two sides are what? If they have the total to 80, what are they individually?
40.
40, exactly.
Okay.
You have 40 across the top, the length.
Mm-hmm.
With the 60.
Okay.
Area.
Okay. And then I just times 60 times 40, and that should give me 240. 2,400.
400.
Okay. All right. That made that really easy. I get it's really easy when you have somebody to break it down to you. Okay. Because I would have, we're not saying never, but I would have missed a step. I think I would have done for that. I just did 60 on both sides, but then when it came up to 40, I think I would have just start with the 80, and I think that would have got me confused from there.
Yeah. So
yeah.
Sum of both of the other two sides.
Right.
To find just one side, the length, so it's 80 divided by 2, not just
right. And that's what I probably got that wrong because I would have did the 80. I wouldn't.
That's why it helps to draw the picture, right? Because if you draw
it does.
You'll do 60, 60. You know, you have 120, you have 80 left.
Right.
Okay, what I put them on top and the bottom, if I have 80 left, I need to do 40, 40, not 80. Because
right.
You can't have 80 and 80 because that's too big.
Right. And it's more than the 200 meters of the fencing as well. So yeah, yes. Okay. That makes sense. Makes sense.
Yeah, the pictures really, really help with not getting, confused on the numbers. Okay, so these are properties of shapes.
Mm-hmm.
You should definitely review these.
Okay.
This one's asking which of the following figures has perpendicular diagonals. So you could quadrilateral, parallelogram, rectangle, rhombus. It's good to like as you study to look at all these shapes and know their properties.
Okay, I will do that.
Note of that because there's a lot of properties, and you need to know like are the diagonals perpendicular? Are they bisecting? Those two things. Are they perpendicular or do they just bisect? Or do they just intersect, which means they just cross, but there's no special way? Or do they cut each other in half, or do they cross at 90-degree angle?
Okay.
So the properties of geometric figures, look those up. See, there's another question about that.
Right.
One of these figures is a quadrilateral. Quadrilateral just means it has four sides.
Mm-hmm.
So a rectangle, yes. A rhombus, yes. A trapezoid, yes. A triangle, no.
No, there's three sides, right?
And then diagonals that bisect. So again, knowing the
That's like crisscross. Okay.
the diagonals bisect means cut each other in half.
Okay.
So not just intersect, but do the diagonals cut each other in half? And then has at least one right angle.
Mm.
So rectangles have right angles.
Mm-hmm.
A rhombus is not. A rhombus is angled.
Yeah. But it's slanted. Yes.
Mm-hmm. Trapezoid does not have to have a right angle, right? Because you can have a trapezoid that looks like looks like you have to have two parallel sides like this, and then you have these. So there's no right angle here. Now you have a trapezoid that is a right angle, like this.
Mm-hmm. It's right there. Yeah. Okay.
But
it just depends how it's shaped.
Yeah. These two sides be parallel to each other.
Mm-hmm.
So these two sides are parallel. But the other two sides don't have to be parallel. So they, like I said, you could have a right angle in the trapezoid, or you could just have a trapezoid that does not have a right angle. And like I said, the rhombus is more like this, where you don't have any right angles. It's like it's slanted.
Because it's slanted, right?
Yeah, so there's no right angles there.
Okay.
So the one that has all of them, that has a right angle, or at least one right angle, is a quadrilateral, diagonals that bisect each other is the rectangle.
The rectangle. Okay. Yeah. Okay. Yeah, I'm gonna study on those more, because I did see a couple of those on the test, and I was like,
Yeah, you gotta know the properties of shapes. So you know what an equilateral triangle is?
Of course it's a triangle, but it has to be all equal sides. Is that what it is?
Right. All the sides are equal, and all of the angles are equal.
Okay.
So if you have how many degrees do you have in a triangle?
I'm not sure.
180.
Okay.
So if you have an equilateral triangle and all the angles are equal, what are the angles? If they have to add up to 180 and they're all equal, what is each of the angles?
Okay, let's see. I think that's wrong. It says 60, but I think I did it wrong. Is it 60 or no? That's too high.
No, 60 is correct. 60.
Oh, that's correct. Okay.
Yep. So 60, 60, 60 is how you get 180. Okay, so, and then you know what a square is and a rectangle, right?
Yes, ma'am.
Okay, so if you look at this diagram, the one that's facing us is the C is on one side and the A is on the other side. So what type of shape is that?
That is what? It's a rectangle.
It's a rectangle, exactly.
Mm-hmm.
Sides have different lengths.
Mm-hmm.
So that's a rectangle. So we know we have that one rectangle.
Mm-hmm.
Then look on the side, you have a B and you have an A, right?
Mm-hmm. That's a triangle.
This is a triangle, and it's isosceles because it's not equilateral because it's not all 60, 60, 60.
Right. Right.
45, 45, and then the 90.
Mm-hmm.
So because only two angles are the same, not all three angles are the same, it's not equilateral, it's isosceles.
Okay.
We have one isosceles that we can see, and then we have one on the back side that we cannot see, right?
Mm-hmm.
So we have two isosceles. So we can eliminate A and B because it says two equilateral. That's not true. We have two isosceles. We only have one rectangle.
Mm-hmm.
So it's not C because C says two rectangles.
Right. And we only have one.
In the bottom of it, you see the A and the A.
Mm-hmm.
That means the bottom is a square.
Oh. I don't
Right.
even see that. Okay.
You see
I
how
was gonna actually break it in half and make that rectangle two squares. That's what I would have done. But
yeah, the bottom, you see how the bottom part, the part is sitting on like a table or sitting on something. It goes
okay.
goes across A and goes back A.
Okay. I see it now. It's taking me a minute, but I see it.
Yeah, so that's
If you turn it, yes.
because it's three-dimensional. But that's a square. Then the other square is on the back side.
Oh, yeah, I see that. That's on the other side by the back of B. I actually can see the end, just the B part, that side right there where you're at. Right. And then the other side is square. Yes, I see that one.
So that's how it's square. So it's D. We have two isosceles triangles. We have two squares, the bottom and the back, and then we have that's facing us.
Okay. Okay. Makes sense.
Okay, let me see if I can find some more algebra. Let's see how you do with this one. This one is involving conversions because it's asking for square yards, but it's giving you information in feet.
In feet, right. And I gotta flip it and change it. Okay. How many yards equal a foot? Is it 16? No, is it 16 feet equals to, yeah. Can't think of it.
So this is the piece of information on your, I think it's on your handout.
Yeah, it's on there.
Okay, so this is something that you know,
I know how to do it because I studied that one too. Just gotta know my stuff. Hold on one second. I'm gonna go get the paper. I'm sorry, I'm looking in this book. Yeah, I thought it was right here.
Yeah, I mean, just so you know, it's good to have that handout handy, but for 1 yard is 3 feet. So you
Okay, thank you.
1 yard is 3 feet, or 3 feet to 1 yard.
Okay, and what no 15 feet by 9. I gotta get to. Okay, so I don't know how to. Can I make it into a proportion style?
Yeah, you can.
Okay. So. One yard, 3 feet, but what is? Something has to cancel out. I'm trying to figure it out. What's the other? Because there's something else that equals. I know 1 yard, you said 1 yard is 3 feet, but there's something that equals something else that would cancel out the yards, just make the feet. Okay. I think I need some help on this.
I'm gonna go to my other screen. Okay, so we know that 1 yard is 3 feet, right?
Mm-hmm.
And it says that you have a rectangular floor.
Mm-hmm.
You draw a rectangle, and it measures 15 feet.
Yes, by 9.
We have to convert these into yards. So we know that we use a conversion. We know that 3 feet is 1 yard. So feet will cancel out. And then we have 15 divided by 3, or 5 yards.
Okay.
Do the same thing with the 9 feet. Times it by the conversion. 1 yard is 3 feet. So the feet cancels out. And then we have 9 divided by 3, which is 3 yards. So our new dimensions in yards will be 3 yards by 5 yards.
Okay. Well, the answer that.
So to find the area, you do length times width. So 5 yards times 3 yards is what? Rashonda, did you freeze on me? Yeah. Hey, you back? Or you're on mute?
I'm sorry, I didn't know what happened. Sorry.
That's okay.
But yeah, I was asking why it got changed into yards. I mean, why it got changed, even though they want to answer in yard, why they didn't just stay into feet?
Well,
That's what
because
I was asking.
they was answering yards. That's why.
Oh, okay. So being that all the answers in yards, we have to convert it into yards.
Exactly. If they wanted to answer,
Okay.
we would have left it in feet. But it
Okay.
specifically said, it specifically asked for yards, for square yards.
Right. Okay.
So that you always know what units to put it in, because you can have it in miles, yards, feet, inches, you know, any type of unit. So you have to make sure that you're, you know, that you are
Yes, ma'am. I got you.
carefully and know exactly.
Okay. Understood. Okay. Cool beans. But I get it now, since that it the way you set it up. And I think, and that's why I knew something had to be crossed out to get into the yard field. So
So then our answer would be
15 yards.
Yeah, 15 square yards.
Oh, square yards. Okay.
Okay, so that was a good practice of converting.
It was, and I it's like I just need to remember it. Just remind myself.
Okay, so this is another, you know, rectangular, again, conversion. Do you want to give this one a try since we just did the other one?
Yes, I'm gonna try this one.
Okay.
So 3 foot wide, foot deck would be the rectangle. Okay, rectangle and draw the shape. 10, 30 feet. Shape. So now just do that. Square yard. Okay, so this is all about the money. So I need to figure, okay, this don't have anything to do with the feet and yards or anything. Okay.
Well, the cost is in is per square yard, and you're
Oh,
giving
okay.
feet.
I didn't see that.
From feet to yards in order to figure out the cost.
Okay. That's 5 yards. 10, 3 and 30, that's 10 yards. So that's 2 feet. So times 2, 55. Times 2. Okay, I got 500. That's what I got, but I must have did something wrong. Yeah, I must have did something wrong. Okay, so what I did was I did the same way that we set up for the yards, and I the 15 feet turned to 5 yards, the 30 feet turned into 10 yards.
Okay, so let me draw it out. So we got our rectangle.
Mm-hmm.
And 15 feet by 30 feet.
Mm-hmm.
And we got to convert that to yards.
Mm-hmm.
You know that 1 yard is 3 feet. So what is it?
that should be 10, right?
It's gonna be 10 yards.
Okay, 10 yards.
And then this one is what?
That is 5 yards.
5 yards. So what's the area of the whole thing?
Oh, I multiplied wrong. 30 is well, no, 5 times 10. That's right.
So what is that?
That's 50. 50 yards squared.
Right, that's the area. And then it says that you need $10 per square yard.
Mm-hmm. So I did 10 times 10. 50 times 10 is what I did.
Oh, hold on. We didn't read the question carefully because we have to build the deck. So
Oh, yeah. Okay.
let me clear this. Because we have to build the deck. So this is not the deck. This rectangle, hold on, let me draw a better rectangle. This rectangle is, here we go. This is the pool. This is the pool.
Right. Okay, we're looking for the deck. So I didn't read the question all right. The thing that's around it.
Going around the pool.
Right, okay.
Wide. 3 feet here. 3 feet here. 3 feet here. 3 feet here. So yeah, this is a pool. So we're not gonna put the we're not building a deck inside the pool. We're building the deck around the pool.
Okay.
The pool measures 15 feet by 30 feet. So this is 15 feet over here, 30 feet over here. Okay, so what we need to do is we need to do what we just did. So we calculated 30 feet to be 10 yards, 15 feet to be 5 yards, right?
Right, yes, ma'am.
And then 3 feet is 1 yard. So
yes.
And 1 yard around. So the area of the pool, we calculated that to be 5 times 10, so 50 square yards, right?
Yes, ma'am.
The area of the pool plus the deck will be basically the bigger rectangle. So what is it from here down to here? We have the 5 yards, but we're going to add on an additional yard to either side, right? So what is the length of the deck plus the pool?
Is it 6? I don't know. I'm so confused right now.
Adding a yard to both sides.
So it's okay, so it's a yard at the top, so that's 2, right? Would that be 2?
Here is 1 yard. From here to here is 5 yards, and then another 1 yard.
Oh, okay, so that's 7.
So it's 7 yards.
Okay. Ooh.
What about this other length going down here?
Okay, so that's 1 plus 10
plus 10
plus 1. That's 12.
That's 12 yards.
Yes, 12 yards.
The area of the pool and the deck is going to be 12 yards
times 7.
What is that?
Top of my head. It's 14. 1. 52, 54. I think I'm doing it with my head. 54, yes. It's 54, yeah, 14.
54, and I'll try again.
Okay, 12 times 7. Let me do it. 84. Sorry.
84 is okay. 84 square yards. So now if the area of the pool is 50 and the area of the pool plus the deck is 84, what's the area of just the deck?
The area of the deck, because the area, 7 times, no.
No, look at the numbers. So we got the area of the pool is 50.
Okay,
And the deck is 84.
okay.
What's just the deck, which is this portion around the pool? What's just the portion around the pool, the deck?
Oh, shoot. I don't know. Okay, the area of the pool is 50, the area of the deck,
The area of the pool and the deck. So the total of the pool and the deck is 84.
Is it 50? I think 5 plus 5 times 10 is 50.
No, if
Oh, that's the pool.
if
Okay.
the total area is 84 and the pool is 50, subtract the 50 to get the deck.
Okay. Wow. Oh,
Right?
yeah. Okay, it's 30. 30 square, 30 yards squared.
84 minus 50?
It's 30. Oh, my bad. Sorry. No, it's not. 34.
34.
Oh, wow.
Yeah, so that's the
This
area.
is a big problem.
Okay, so we found the area of the pool. We found the area of the pool and the deck and subtracted the two to get just the deck, because the deck is the part that we need to buy. What are we buying? Lumber. It's $10 a square yard. So we know we need 34. We have 34 square yards, and it's $10 per square yard. So how much is that going to cost?
34 times 10. No, wait. $340.
Right. All right, you good with that one?
Yes, there's a lot, but I'm getting it.
Okay, does it make sense?
Yeah, it's making sense. It's making sense. It's gonna make sense because I gotta get it.
Yeah, so that's because that's asking you to convert, right, between the feet and the yards. Also asking you to think about like a big shape minus the shape in the middle.
Right.
To get the border. It's almost like a picture frame, right?
Right, because that's kind of what it looks like. Yeah.
You have a picture in the middle, and then you have the part outside the frame. If you wanted to calculate just the frame part, right, then you would need to subtract the full frame, the whole shape minus the picture.
Minus the picture, right, to get
the border. It's like a border.
The border, right.
So
okay.
Whether you have a frame or a pool with the deck around it, whatever it is, it's still the biggest rectangle minus the smaller rectangle to get the portion just going around it.
Okay,
With a donut or a circle.
right. And you just want to find the inner hole.
Big circle minus a circle in the middle, you take that out, and then you just have the donut left over.
Yeah, okay. That makes sense. Lots of sense. It's just I didn't see it at first. I just only did a couple of steps and then finished the rest.
All right, let's try this inequality.
I can't see it. It's still on the whiteboard. That's why I didn't start it, because it wasn't on the whiteboard. It was on the whiteboard.
I thought I had moved it over. Okay, can you see it now?
Yes, ma'am. Okay. I must have did another step. Wait, I'll do it. I got 0. I don't know if that's right. That's what I got.
Got 0?
Yes.
You're correct.
Oh yeah, I did it right. Yay.
Oh.
Awesome.
Yeah, because if you plug in 0, you'll get -3 is less than 1 is less than 5, and that is correct.
Yes.
Okay, so I know you have to go, but
Yes, ma'am.
I definitely recommend that you go through all these questions, you know, on your own, just to kind of, there's only 45 of them total, so it's not a whole lot of questions. And, you know, whatever other resources in terms of like books or practice tests, hands-on, as many as possible before you take your real test. Because, you know, the best way to do well on any test is do a lot of practice problems.
Right.
So, you know,
Different ones, but the same type of questions, but different problems.
exactly.
Yeah.
So that way, when you take your real test, there'll be nothing on the real test that you haven't seen before.
Right, because I went over it. Yes.
So the more you do, you're walking to the test feeling really confident because you'll know what to expect.